Hi, this is John Block from Mr. Block Tutors Math, and I answer math questions and stuff. And one thing I've noticed, a lot of questions come out of this problem, a problem like this. And it's this problem: Fred stands on a roof 20 feet above the ground. That's going to be important. He throws the ball up in the air 96 feet per second. And then here, we're going to look for when will the ball reach its highest point, and then what is the highest point, and when will the ball hit the ground? Those three questions. Now let's draw our situation. So we've got this 20 feet, and we're going to assume that Fred's throwing from 20 feet. And he throws the ball directly up into the air, and it comes down and so forth like that. But in order to make this work in math, we're going to put it on an axis, and we'll call the bottom of the building 0. And we'll call this the h-axis. This is the t-axis. And our formula right here that we're working with is h of t, or just h, equals, now, our initial velocity times the time minus 16t squared plus our initial height. Now there's your basic formula for these throw the ball in the air problems. And when you have a problem where Fred's just standing here and dropping the ball, then you just simply cross out this part, and then this is your formula. Now, where's all this coming from? Well, his initial velocity is 96, so you're going to have to multiply velocity times the time it's in the air to get that distance, that up distance. This is a down distance right here, this part, and that comes from gravity. So the velocity due to gravity is 16t, so we have to multiply by another t. Velocity times time equals distance. So that's where we're getting 96t minus 16t squared. And his initial height is 20 feet. Now there's your formula right there. That's h, his height is. Or you could say h of t if you wanted to. Now notice something about this. What kind of graph is this? Especially if we turn it into this. 16t squared. Let's just to rearrange this, use our commutative property. Remember that property from elementary school or junior high math? We'll flip those two over around. What is that guy right there? And you should be thinking that's a parabola or a quadratic. And quadratics have this nice characteristic as they, let's see if I can draw one. They're symmetrical. That's supposed to be symmetrical. Whereas this, and then here's your height right there. So this will be your time, your highest time, t, I'll say t highest. And then this mark right here will be your actual height that it takes. Now notice something about this. This graph, we're thinking, when will the ball reach its highest point? How do you find this time right there? Well, think about this. If this is 20 right here, that point right there is the point 0, 20. See, time versus height. Right straight across from this point is another what? Another 20, isn't it? So if I know that straight across from that is another 20, I'll replace height with 20, and I get negative 16, or over here I'll copy the rest of the problem down. Can I solve that problem right there? Well, what do you notice? What can be subtracted out right away? Well, the 20s. I could subtract a 20 away from both sides, and that gives me 0 equals negative 16t squared plus 96t. So then I'm going to solve this, set this equal to, and notice you could do some factoring right here. What could we factor? We could factor out 16 and there's a common t, and that would give us negative t plus 6. Now remember, when you factor, the reason why you factor is to get easier equations to work. So if something times something equals 0, one of them or both of them have to be 0. So then I can set these two factors equal to 0, and then I get t equals 0, which is right here. And I get right here t equals 6. So I know that this 20 feet is at the 6-second mark. What's this one have to be, the highest t? It's got to be what, since this is symmetrical? It's got to be 3 seconds. So there, we just found that part of the problem. When will the ball reach its highest point? At 3 seconds. Now, in order to find the next part of the question, all we have to do is take the 3 and plug it into t, and that will get us the highest point. Let's do that. Okay, so we plug the 3 in to here. 3 times 96 is 288, and the 3 here, so that'd be 9. 9 times 16 is 144. 288 minus 144, and so forth, and we get 164. So that's the rest. So this point right up here is the point 3, 164. 3 seconds, 164 feet. Now, when will the ball hit the ground? Well, what's h when it hits the ground? That's this point right here. What's h? H equals, obviously, 0. So all we have to do is take a 0, plug that in, and here we've got our 96t minus 16t squared plus 20. Now, let's take a little bit of time right here and switch these two around so that it makes it look like a quadratic equation. So I've got negative 16t squared plus 96t plus 20. And there's our a, there's our b, there's our c. Or we could divide 4s out, divide by 4, divide by 4, divide by 4, divide by 4, and get negative 4t squared plus, would that be 24t plus 5. There's a, there's b, there's c, and use our quadratic formula. I don't think it factors. Use your quadratic formula, and let's see. Let's stop it here and write that. So I took some room here, went up here to my quadratic formula, plug it all in, and you should get about 6.2, something like that, seconds. So 6.2 is when it hits the ground, 6.2 something. Okay, well, that's all for today. That's that interesting balls being thrown into the air problem, or ball being thrown into the air problem. You can reach me at Math Music Farm. If you have a question that you need, a math question you'd like answered, just type the question out or write it out and send it to me at mathmusicfarm@gmail.com. and I'll do my best to answer it for you and get the answer back. And if you're interested in tutoring, you can also email me at that place and ask about tutoring. All right, thanks. We'll see you.